Your organization has multiple AWS accounts for different teams. You need a centralized way to manage security, detect vulnerabilities, and enforce compliance across all accounts. Options: A. Use AWS Control Tower with AWS Config. B. Use Amazon Inspector in each account. C. Use AWS Security Hub with AWS Organizations. D. Use CloudTrail with IAM policies. Correct answer: C. Use AWS Security Hub with AWS Organizations. Explanation: Security Hub integrates with AWS Organizations to provide centralized visibility into security findings, compliance, and best practices across accounts. Why not other options? Option A. Control Tower helps set up multi-account environments, but doesn't provide ongoing security monitoring. Option B. Inspector is for specific vulnerability assessments and would require manual setup in each account. Option D. CloudTrail provides logging but doesn't enforce compliance or security monitoring. You need to process files uploaded to S3 by performing ETL operations and saving the transformed data back to another S3 bucket. The solution must be serverless and scalable. Options: A. Use Lambda with S3 event notifications. B. Use Glue ETL jobs triggered by CloudWatch events. C. Use EMR clusters with Apache Spark. D. Use step functions with Lambda and DynamoDB. Correct answer: B. Use Glue ETL jobs triggered by CloudWatch events. Explanation: AWS Glue is purpose-built for ETL workflows, and triggering it via CloudWatch events allows serverless, scalable processing of S3 uploads. Why not other options? Option A. While Lambda can process files, it's not ideal for complex ETL tasks involving data transformations. Option C. EMR is overkill for a simple ETL workflow and requires infrastructure management. Option D. Step functions can orchestrate workflows, but Glue is more efficient for ETL-specific tasks. Your application experiences unpredictable traffic spikes, especially during flash sales. It must handle the spikes automatically without downtime and keep costs low. Options: A. Use an auto-scaling group with EC2 instances. B. Use AWS Elastic Beanstalk with auto-scaling enabled. C. Use AWS Lambda with API Gateway. D. Use EC2 instances with a fixed capacity and elastic load balancer. Correct answer: C. Use AWS Lambda with API Gateway. Explanation: Lambda with API Gateway automatically scales based on the number of requests and is serverless, reducing costs when the application is idle. Why not other options? Option A. EC2 auto-scaling is effective but incurs costs for instance management even during idle times. Option B. Elastic Beanstalk simplifies deployment but still requires EC2 instances, leading to higher costs during idle periods. Option D. Fixed capacity can't handle unpredictable traffic spikes. A company wants to keep frequently accessed data on-premises while moving archived data to AWS. The solution should allow seamless access to archived data without manual transfers. Options: A. Use AWS Storage Gateway with the File Gateway configuration. B. Use S3 with lifecycle policies. C. Use AWS Data Sync to transfer data periodically. D. Use Amazon EFS for storing archived data. Correct answer: A. Use AWS Storage Gateway with the File Gateway configuration. Explanation: File Gateway enables local caching of frequently accessed files while storing less frequently used data in S3, making it ideal for hybrid cloud storage. Why not other options? Option B. Lifecycle policies are for managing S3 data, not on-premises integration. Option C. DataSync transfers data but doesn't provide seamless access to archived files. Option D. EFS is a fully managed file system but doesn't provide hybrid storage integration. Your company's primary database is hosted on RDS. You need to set up disaster recovery in another AWS region with minimal downtime and data loss. Options: A. Use multi-AZ RDS deployment. B. Use cross-region read replicas and promote them during failover. C. Use AWS backup for daily snapshots. D. Use DynamoDB global tables. Correct answer, B. Use cross-region read replicas and promote them during failover. Explanation: cross-region read replicas allow replication of the database in another region. Promoting a replica during a failover minimizes downtime and data loss. Why not other options? Option A, multi-AZ deployments are within a single region and don't protect against regional outages. Option C, AWS Backup doesn't provide real-time replication, recovery involves downtime. Option D, DynamoDB is not a relational database and isn't suitable for RDS workloads. Your company provides a global API service used by customers in the US and Europe. The API needs to achieve low latency for users in both regions while being cost-effective. The service requires a failover mechanism to handle regional outages. Options: A. Deploy API Gateway and Lambda in one region and use Route 53 latency-based routing. B. Deploy API Gateway and Lambda in both regions, using Route 53 latency-based routing. C. Deploy EC2 instances behind an ALB in one region, with CloudFront caching for global distribution. D. Deploy API Gateway in one region with DynamoDB global tables for regional replication. Correct answer, B. Deploy API Gateway and Lambda in both regions, using Route 53 latency-based routing. Explanation: API Gateway and Lambda in multiple regions provide low latency by serving requests close to the user. Route 53 latency-based routing ensures that users are directed to the nearest region. In case of a regional outage, Route 53 will redirect traffic to the healthy region. Why not other options? Option A, deploying in one region increases latency for users in the other region and fails to meet the failover requirement. Option C, EC2 with ALB is more expensive and requires infrastructure management compared to serverless API Gateway and Lambda. Option D, DynamoDB global tables solve the data replication issue but do not address API latency or failover. Your company wants to implement a data lake for storing structured, semi-structured, and unstructured data. Data needs to be ingested from on-premises systems and queried by analysts using standard SQL. The solution must be cost-effective and scalable. Options: A. Use Amazon S3 with AWS Glue and Athena. B. Use Amazon Redshift with Spectrum and Kinesis Data Firehose. C. Use DynamoDB for storage and Amazon QuickSight for analytics. D. Use S3 with EMR and Hive. Correct answer: A. Use Amazon S3 with AWS Glue and Athena. Explanation: S3 provides cost-effective, scalable storage for a data lake. AWS Glue catalogs the data, and Athena enables serverless SQL queries on S3 data. Why not other options? Option B, Redshift Spectrum is effective for querying S3, but Redshift introduces higher costs for maintaining a cluster. Option C, DynamoDB is a NoSQL database, unsuitable for a data lake. QuickSight is for visualization, not querying. Option D, EMR with Hive adds unnecessary complexity and higher costs compared to serverless Athena. Your multi-tier web application is deployed on EC2 instances in a single region. You need to implement disaster recovery, DR, in a secondary region to minimize downtime during a regional outage. The RTO is 4 hours, and the RPO is 1 hour. Options: A. Use multi-AZ deployments for EC2 and RDSB, set up a pilot-light architecture in a secondary region with replication. C. Deploy resources in the secondary region and configure them as active-active. D. Use AWS Backup for EC2 and RDS snapshots and restore during failover. Correct answer: B. Set up a pilot-light architecture in a secondary region with replication. Explanation: Pilot-light architecture keeps minimal resources running in the secondary region, e.g. database replication and a small app server footprint. During failover, scale resources to handle full production workloads, meeting the 4-hour RTO and 1-hour RPO. Why not other options? Option A, multi-AZ is within a single region and doesn't address regional outages. Option C, active-active increases costs significantly and is unnecessary for the stated RTO and RPO. Option D, restoring from AWS backup may exceed the 4-hour RTO. You are migrating a high-performance OLTP database from on-premises to AWS. The database requires low-latency access and supports over 100,000 transactions per second. Options: A. Use Amazon Aurora with multi-AZ. B. Use Amazon RDS for MySQL with read replicas. C. Use DynamoDB with on-demand capacity. D. Use Amazon Redshift for high-performance queries. Correct answer: A. Use Amazon Aurora with multi-AZ. Explanation: Aurora is designed for high-performance OLTP workloads, supports low-latency access, and scales to handle hundreds of thousands of transactions per second. Multi-AZ ensures high availability. Why not other options? Option B. RDS MySQL has lower performance limits compared to Aurora. Option C. DynamoDB is for NoSQL workloads and lacks relational database features. Option D. Redshift is designed for OLAP workloads, not OLTP. Your company processes terabytes of data daily using EC2 instances running Spark jobs. The jobs run during business hours and remain idle otherwise. The company wants to reduce costs without affecting performance. Options: A. Migrate to EMR with spot instances. B. Migrate to AWS Glue for serverless data processing. C. Use auto-scaling with EC2 reserved instances. D. Use EC2 with savings plans. Correct answer: A. Migrate to EMR with spot instances. Explanation: EMR with spot instances significantly reduces costs by leveraging spot pricing for Spark jobs. EMR automatically provisions and terminates instances based on job requirements. Why not other options? Option B. AWS Glue is serverless but may not handle Spark workloads efficiently for terabytes of data. Option C. Reserved instances are more expensive for workloads that aren't continuously running. Option D. Savings plans offer discounts but don't reduce costs as effectively as spot instances for intermittent workloads.